Bismillahirrahmanirrahim. Assalamu alaikum. Welcome to another video of Chem Solve. Today we are going to start another important playlist of our YouTube channel, and that is Introduction to of Organic Chemistry. So let's start it. Let me write the name of the title first. Okay, so first, in order to talk about organic chemistry, we need to understand what are hydrocarbons. So another important definition is hydrocarbons. Okay. As the name indicates, the word hydrocarbon comprises of two words. One is hydro and the other is carbon. So hydrocarbons are basically the compounds which contain carbon and hydrogen only. This word is very important because hydrocarbons are the ones which have only carbon and hydrogen in their formula. For example, methane. For example, ethene. My dear student, just look at the formula. Can you see any other element here? The one is carbon and the other is hydrogen, and that's it. There is no other element present in hydrocarbon. Hydrocarbons are the ones which have only carbon and hydrogen in their formulas. Okay? I think you have understood this. Now let's talk about organic compounds. So another important definition of today's topic is organic compounds. Okay, so what are organic compounds? Organic compounds are those compounds that contain hydrocarbons, which we have talked about it, and their derivatives. This word derivatives is very important here. What does this mean? Let me give you an example, and I hope you will understand it with the help of example. For example, C6H12O6. Okay, now compare hydrocarbons with the organic compound. Organic compound contain hydrocarbons. I mean, they contain carbon and hydrogen, but they also contain some other element as well. Here you can see it contain oxygen as well. So hydrocarbons are the one which contain only carbon and hydrogen, but organic compounds contain carbon and hydrogen. This is the backbone, this is the skeleton. It must be there. But in addition to hydrocarbons, there is and maybe you may or may not be some other element present. For example, oxygen, for example sulfur, for example nitrogen. Okay, so some other element may also be present there in addition to the main skeleton, in addition to the main two elements, carbon and hydrogen. I hope you have understood the topic. And this study and the study of organic compounds is called organic chemistry, which is our main topic today. Okay, so let's move to the next definition of today's topic, and that is homologous series. If you people are taking bio as well, then you can well understand what does the word homologous mean. In science, basically homo means same. So homo mean same. Okay, so now let's understand the definition. Homologous series is the family of organic compounds with the same functional group and similar chemical properties. As you can see, I have highlighted two words here. One is functional group and other is similar chemical property. We will discuss about the similar chemical properties a bit later. First, we must discuss what are the function group. But before talking about the function group, let me tell you what are some of the examples of the homologous series that are being included in our GCSEs and IGCSE syllabus. The one is alkane, alkene, alcohols and carboxylic acid. Don't worry at all, we will discuss all of them, alkane, alkene, alcohol and carboxylic acid, later in this series, inshallah. So, we are going to discuss functional group now. In order to understand homologous series, we should understand function group first. Okay. A function group is an atom or a group of atom that gives a molecule its Characteristics, properties. Basically, it could be a single atom, or it could be a group of atom. Even it could be a single bond, or it could be multiple bonds. For example, double or triple covalent bond. So it could be an atom. For example, it could be only chlorine, or it could be the group of atom. For example, it could be COOH, which contains a group of atom. For example, carbon, oxygen, and hydrogen here in the case of COOH. Or it could be a single bond between two carbons, or it could be a double bond between the two carbon. So all of these are known as a function group. And all the elements having the same function group, basically they show a similar properties, especially the chemical properties. So if we know the function group, then we can discuss, then we can have an idea about the properties of that organic compound. And the organic compound which have the same function group, they belong to the same homologous series. You must remember that a while ago I gave you the example of the homologous series, that it could be alkane, alkene, alcohols, and carboxylic acid. So let's see that what different group does those alkane, alkene, alcohols, or carboxylic acid exhibit. So for example, let me draw a table over here. Okay, so function group, the name, and of course it's, give me a second please. Okay, name, functional group, and example. Okay, so the first name is alkane. Alkane have carbon-carbon single bond in between. The example is CH3, CH3, ethane. Okay, next function group we have is alkene. Alkene mean it would have carbon-carbon double bond in between. So here there would be a double bond in between the two carbon, and in order to satisfy the valency of 4 for each carbon, I have to write 2 carbons here, and the name is ethene. Don't get confused by the name. In the next topic, inshallah, we will talk about how to name the organic compounds. The third function group we have here is alcohol. Alcohol has OH function group. For example, 2 carbons, and they have alcohol function group. The name would be ethanol. And the last one is carboxylic acid. The function group is COOH, So A3C, COO, and the name is ethanoic acid. You must be surprised that how do I'm gonna name these ethane, ethene, ethanol and alcohol. So let me discuss it. Next topic is naming the organic compounds. Okay, basically there are two steps in naming the organic compounds. The one is their prefix and the other is their suffix. Okay, what are the prefixes here? The prefixes are the number of carbon atoms in the molecule, and suffixes are name the functional group present. So in this way, just by looking at the name of the molecule, we get to know that which functional group is present. Alright? For that, I have to draw another table. Okay. So first we have to write number of carbon atom. Second is for alkanes, then for alkenes, then for alcohols, and lastly for carboxylic acids. Okay, so now discuss it, but you must remember that for alkane, the suffix that we add is "ane", and for alkene we add "ene". For alcohol we add "ol", and for carboxylic acid we add "oic acid". Okay, we need to remember them while naming the organic compounds. So when carbon number is 1, let me write the carbon number first. Carbon number is 3, carbon number is 4, carbon number is 5. So when carbon number is 1, it is called meth, then eth, then prop, then bute, and pent. So, for example, if we have carbon number 1 alkane, so it would be meth, and at the end we will add ane, so it would be methane. Eth, and at the end we will add ane. Prop, and at the end we will add ane, propane. Bute, butane. Pent, ane, pentane. We don't have carbon number 1 alkene, so there wouldn't be any name for it. It starts from carbon number 2, so eth and ene, ethene. Prop and ene, propene. Bute, ene, butene. Pent, ene, pentene. And for alcohols, we will use alkane name, but we will just drop its E. Okay, so it would be methanol, ethanol, propanol, butanol, pentanol. Again, same goes for the carboxylic acid. In the name of the alkene, we will just drop E and we will add oic acid here. So it would be methanoic acid, ethanoic acid, propanoic acid, butanoic acid, pentanoic acid. I hope you have got it. Okay. For example, if you have propene, so how will you recognize it? It has, for example, H, C, single bond C, double bond C, H, 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 and H. Now the carbon number are 3, so carbon number is 3, so it would be prop, and it has a double bond, so it would be ene. By joining them, the name become prop and ene, it becomes propane. Now discuss another example. For example, if we have carbon number 2 and we have OH function group here, let me complete hydrogen. Okay, so carbon number are 2 here, so it would be ethane, and function group is OH, it means it would be ol, so we just have to drop the E and add them, so the name becomes ethanol. And here you go. Now coming towards the last topic of today's lecture, that is journal characteristics of homologous series. Okay, so what are the characteristics of a journal homologous series? The first one is okay. So the first one is they all have same functional group. Remember, this was the first thing that we discussed in today's lecture, that if something belongs to the same homologous series, then it would have the same function group. If I say that ethanol and methanol are both alcohol, it means they would have the same function group, and that is OH. And they would have similar chemical properties. Their behavior towards their chemical properties would exactly be same. For example, if I say that ethanol react with water, or if I say that ethene react with bromine, it means propene will also react with bromine. All the alkene will react with bromine. Okay? And there is a gradual change in their physical properties as we move down in a homologous series. For example, if methane is the first member of alkane, and I say that its melting point, for example, is minus 182, then the melting point of the ethene wouldn't be 283. It would be gradually change. If one is 182, minus 182, the other must be 183, 184, 185, and the next would be 188 maybe, and next would be 190, next could be 195 maybe. I mean to say, there would be a gradual change, there would be an orderly arrangement in the melting and the boiling point, or in all the other physical properties. There wouldn't be a sudden and abrupt change. I hope you get it. Thank you so much. This is all for today's topic. Inshallah, see you next time. Allah Hafiz.